So are we ready? So before we start, Andrea, just give me 1 second. We are going to, if it's okay for you, close down the votes for the AI Awards. Is there still someone who needs to vote? Who has not voted yet? No? Yeah, je te vois. So we will now officially close the votes for the AI Awards, and the results of the AI Awards will be visible in exactly 58 minutes. So my next speaker, no, not my next speaker, your next speaker is Andrea. I've asked her to be herself and to talk from her heart what she does as a CTO of Boston Consulting Group Gamma. Andrea, you are more than welcome here in Brussels. Go for it.
Thank you, Philippe. So thanks everyone for joining. As Philippe said, I am BCG-Gamma's Chief Technology Officer and the founder of our ML and AI product called Source AI. And today I'm going to speak about AI at scale. It may not be super technical, but there's a reason for that. I want you to remember a few things walking out of this room that are hard lessons learned in trying to scale 3 products at 2 different companies in the span of 5 years. The prior, which was McKinsey's Quantum Black. So I hope some of them stick with you. And if you want more nitty-gritty tech details of our product, we're always happy to provide those. So, AI. I chose this picture because this is how I feel every person I talk to who kind of knows something about AI, even some experts feel. It's super interesting, they're curious, but what does it really do? How much power does it have? Does it scale? If it scales, can we manage it? If AI starts to build AI, what happens? So we're still kind of peering over the edge, waiting to see what will happen. However, because of that, we do all the things, everything. We try it all. We dabble, we get our feet wet, we do cryptocurrency, we do distributed ledger management, we do machine learning of all forms, we do what we call artificial intelligence, we do deep learning, we do shallow learning, medium learning, all kinds of learning. And that is when we have a bit of an issue when we try to scale things, because we don't focus. So one of the key learnings when we try to do AI at scale is what we realize is pilots and pilots and pilots of fun. There are pilots everywhere. I think I've been in the business, now for 6 or 7 years. I have yet to see more than 30% of pilots go to full scale. And yes, one of the reasons may be that we don't have enough engineers, that we don't have enough data scientists, that we're struggling to recruit. But I think we are all, as the first picture showed, a little enamored with what artificial intelligence can do. And for that reason, we're really losing some of the focus. And one of the reasons why we like BCG and Gamma and what it brings together is that we have a very use case-driven methodology to say, what are we doing? Why does it matter? How long is it going to take to get there? And is it truly going to change and impact something? And so focus and precision are quite important. How do we do it? We built a product with a very clear focus in mind. A lot of people were doing the data side. We know that data is hard to integrate, it's hard to manage, it's hard to aggregate, clean. We all know the story, it's 80% of the problem. But, Trifacta, Dataiku, Collibra, IBM's suite of data services, we thought probably not best to tackle that problem. The modeling layer. Okay, ML flow, Kubeflow, Airflow, probably a flow I'm not mentioning, Jupyter Notebooks, Jupyter Lab, Domino Data Lab. So we thought, all right, the modeling layer kind of has some competition. Deployment. Who's deploying models at scale really, really well? Not a lot of people. Let's try to tackle that. So we started trying to tackle that 14 months ago, I believe, on a whiteboard. And we said, all right, we know what we're going to do. We're going to make this super easy, very generic. Everything's going to be done in containers. We're going to do something super fancy called container hydration. All the production's going to happen in the background. We're going to have thousands of Kubernetes clusters. Everything's going to be secure. We're going to file 5 patents, and BCG is going to change the world. This page doesn't show all of that because we've had some learnings in that space. Mainly that it's very hard to scale and make multiple AI models generic. However, if I can walk you through some of this, we did actually win a lot of success in getting Source AI to really become one of the best-in-class deployment tools. And that's a very big thing to say, I know, because AWS SageMaker's out there, and Data IQ's out there, and Data Robot's out there. But if you do look us up, we do have 2 awards, and we do have a patent on container hydration. And we have 2 awards, one from Docker for being a rising star in 2018, and HashiCorp for being the best user and challenger of their entire Hashi stack. So we've also broken Terraform about 5 times, maybe more at this time, and we've contributed to it as well with a Terraform provider. So as you can see here, the way Source AI works is we have at the front end, we sit on top of any object store. So that's S3 right there as AWS. And then you ingest your data into a version data store using an open source library called Pachyderm that we've also helped build. It's a startup in San Francisco that we've helped build. And that actually versions and manages all your data kind of like GitHub does for code. So every time you insert a data set, it gets stored as if it was a commit. And every time it gets changed or updated, it also gets stored. And then obviously you can see here that we have a UI that lets you manage a bunch of stuff that you may have seen in our booth. We have Jenkins doing some work, and then we have a number of data science notebooks working for you. These data science notebooks have every package known to man in them. So they have TensorFlow, they have, they have everything down to Orange and some other things, some other more esoteric data science packages. They have, as of today, they have Garobi optimization in there. I think we are the only deployment tools to actually have Garobi inside its product for optimization. And this case cluster that you're looking at here is completely independent in its own. It's completely secure. And so it cannot share data with any of the other clusters being managed by our Kubernetes infrastructure. And then as you can see here, we are a HashiCorp family. So we use the entire HashiCorp stack. We use Vault for dynamic secrets management, which means no one touches a username or password. It's all managed by a machine and rotated to keep the credentials fresh. We have Terraform. Terraform is an interesting use case. So, scale again. We got into a situation where we said, if Source AI falls down and no one is there, who's going to tell Source AI to start itself? And this one engineer we had said, we're going to tell Source AI to tell itself to start itself. All right. The code began to be written. We ended up with some interesting recursion problems. But sure enough, there is a Terraform piece of code in there that actually triggers Source AI to start itself if it fails. So we have true, as defined, zero-touch infrastructure. Now, obviously, if it breaks and we have some esoteric issues, we do have some level 3 things that have to be fixed. But in terms of big failures, it will spin back up. Service discovery, obviously, everyone knows Circle CI. And then we do a lot of monitoring on the top and Docker Trusted Registry. So our container hydration. I'll speak to it as high level as I can because the patent is pending for a few more months. But essentially what that does is it takes your code that you are training that has all the dependencies attached to, let's say you use 20 packages and 1,000 lines of code, but to go into actual predictive application, you only need one of those packages and 10 sets of that code, but you need to package all those dependencies so that that container can run independently of Source AI. This is what we call container hydration. So we hydrate the new container with the old material that you have using some very specific set of code, and that allows you to move your model absolutely anywhere with zero dependency on Source AI. So that's how we do it today. That's 1.0. 2.0 has other really cool things like single-click web deploy, Spark, native Spark integration, and a couple more things, fancier UI, things like that. But that comes out in November. So that is how we try to scale AI today on the technical side. So I'm going to do this real quick. All right. So then there's the then there's the user side. One big mistake we made was, which I really thought I was not going to make, we really focused on the tech. It was so hard to scale and so complicated to do that we thought about only the tech. But then we realized, hold on, there's all these users. They all have desires. And those desires are actually common, right? They create nodes amongst each other. And then on top of that, desires are things like, I'd rather the interface be blue. I'd rather scroll left than right, whatever, right? And then needs are compute power, C++ instead of Java, things like that. And so we started realizing, as any of you guys that know DAGs, this started to get super complicated, and it had nothing to do with the tech. And we completely ignored it, and 1.0 did not go so well. Now, we have over 700 data scientists at Gamma, so we're very lucky to have a very rich and opinionated user pool. And so we got some very fast iterative learning here. And so, yes, the technology was important, but we actually ignored the user quite a bit. And we realized that the data scientist can actually be broken into over 50 personas. The citizen data scientist, the expert data scientist, et cetera. And so we're still working on figuring those personas out, but this was something that we definitely realized was hindering our scale beyond just super cool tech. So, yeah, it's not all peachy, right? So if you're not tired, you're not doing it. You're not doing it right. I think we're all trying to go really fast. I think we're all trying to beat the market. And I think what we're realizing is that a lot of these products and things that are coming out, who just saw the acquisition of Looker to Google? And Tableau? Yeah. So I see the same thing happening in AI. Lots of things spinning up, all kinds of cool stuff, and then it's going to shrink back down to size, and the few are going to be left. So it's not going to be all peachy. It's hard. Slow down a little bit to speed up. It's a old idiom, right? But it's a cliche as well. But it works, especially when we don't even know the repercussions of what might happen. So who here knows the Allen Institute for AI? Yeah, awesome. All right, that's like the most hands I've seen ever since I mentioned them. So they have an awesome article in Wired magazine that really spoke true to me on how far away we are from getting to AI at scale in its truest form. So they told a robot to go look for a tomato in a room. And the tomato threw tables over. The robot threw all these things. He went behind couches, all these sorts of things, and then he came back with nothing. Then they spent a ton of money on AWS Mechanical Turk to hard code intuition into the robot. You should read the article. They sent the robot back, and the robot opened the fridge, went into the fruit department, and took the tomato out. They said in order to do that, for every AI we have out there today would take over 50 years just to get started. So no intuition, right? No self-learning yet, but we're moving really fast thinking we can do all of this at scale. So I think we really have to think about the limitations and what that actually means. Flexibility is key. So this is a UI example of our product. And another thing we noticed here when scaling out was we've got people that want their IDE, regardless of what we tell them is easy or not. They really want to feel, first they want a dark theme. And secondly, they want to be at the layer of, they want to be at the IDE, right? So we put Visual Studio Code inside of our web UI, and then we still offer Jupyter notebooks, which, by the way, are all synced to GitHub. So for those of you who use Jupyter, I'm sure a lot of you do, there is no push to Git. There is in source. So flexibility is key, especially when you're trying to be a little a little mindful of how long your product is going to survive. So one thing I always like to say is building a true product that is impactful and enduring takes scientists, it takes painters, it takes visionaries, creators, more than just engineers. And this is because we are building tools to serve our society. And so our people that represent that society should be also building these tools, right? A good example is how many of you have seen HBO's Westworld? He is on staff at BCG-Gamma. So Chris Kiefer, who is responsible for Westworld, Marvel, Star Wars, Star Trek, I'm sure I'm missing one, Godzilla, Passengers, and Interstellar, is our UI advisor. And why? Because we're trying to bring the impact of filmmaking into the design of artificial intelligence, right? Why not? You see a film, you love the story. Why not bring that into what we write today? Now, last but not least, come on, guys. Treat your engineers with, you know, the tech is ready, but are we, right? So I think the final thing that I leave us all with is one of the other reasons we chose to build Source is because we really want our data scientists and our engineers to empathize with one another, to speak the same language, to talk to one another, and to understand that they're there to be a force once they're together versus antagonize each other on your code's not strong enough, you're too strict, you only write in script, your functions are 5,000 lines long, why do you still write in C++, why are you writing in Julia, right? So I think those are great conversations to have over lunch and dinner, but together we should all work on one platform and make AI scale. So I will leave it at that, and good timing, my time is up. So, of course, I don't know if there's going to be Q&A, but if you guys have questions afterwards, I'm around. Thank you.
Excellent. Thank you very much. So our next speaker is new to the team, and she's going to give you a short introduction to what AI training should be all about here in Belgium. Let me please introduce you to Michèle.
Thank you. Good afternoon, everybody. So, waiting for my... Okay. Cool. Okay. No. Okay. So, good afternoon, everybody. I would like to introduce you the Academy. And I need, oh gosh, sorry. Wait a minute. Okay. Sorry. Voilà. So I need to be quick because I know I got only five minutes, right? And I would like to catch up your attention during these 5 minutes. So, you know, all what is important, it's the ongoing training, ongoing education, okay? You know, it's right, nothing very important there to say that new and additional skills around the data are always needed. And I did myself a little search. I searched for data scientists in Belgium. And look what I found. Only on 2 sites, more than 400 job openings in LinkedIn and almost 300 for Glassdoor. And I found also this report from Glassdoor who said that, who mentioned the highest paying entry-level job in the US for this year. And guess what? Data scientist is the first. And is the first, and also with a high satisfaction rate. So people are really well paid and they really like what they do. So this is not bad at all. And now, this is our focus at the Academy. So we really want to organize really tailored training, which really in regard to your business needs. So let me explain you our approach. So we have the companies, so could be yourself. I guess that there are companies in the room who need the right people with the right skills. Not always easy to find. We do have the job seekers, and by job seekers could be young graduates, could be entrepreneurs, could be professionals who just want to update their skills. And then we have the coaches who love to share their knowledge. And in between these three actors, there is the academy. And the academy is aiming to be the link between these three actors and make sure that we are fulfilling the needs of these three actors by offering really tailored trainings. So let's say that I'm a job seeker, so I would be interested by gaining a lot of expertise. I would like to have a job I really like. I would like to feel a high level of satisfaction. Maybe the salary could be important to me as well. I would like to be part of a community, whatever, etc. What at the academy we can offer is a 9-month program, and that is the case for a boot camp on data science we're going to be organizing soon. We offer you a proven concept of learning. We offer you a networking to be part also of a community, and also really important, a lot of job opportunities. So let's say that now you are a coach. So a coach, they are, and I know I've met a few, they are interested by sharing their knowledge. They are very enthusiastic, and what they don't like the organization. They don't want the hassle of the logistics and so on. They want to build their reputation. They want to also to meet their peers. They want to have a job they liked. And what we offer, it's really, we will do that. All the logistics to put the program together, to contact the participant, we do that for them to make sure that they do just what they love to do. We offer them a good networking, also be part of the community, and etc. Let's say now that you are leading a company, of course. Objective is different. You are interested in recruiting the best people with the best skills you need to move forward in your business. You want also to train your actual teams and with the best experts you can find on the market. And of course, you want to do that in a quite cost-effective way. And again, the academy is offered that to you. We do have a training method with proven track record. We have a flexible approach, meaning that we are listening to the business needs, and our program are evolving. We organize regular job fairs. And again, we are offering an affordable way of recruiting. So our concept, it's, as I said, it's a proven concept. Two important things already mentioned. Our training are evolving depending on the needs of the market. And the beauty of our training is really that they are structured in two parts. The first one is very kind of the fundamental, the theory, with online learning and also coaching, because we believe that only online learning is not a solution. It needs to be with coaching. And then the part two, which is crucial as well, it's a long period of hands-on business cases to be solved on-site in a company. And then I would like to take the opportunity of this meeting to announce the launch of our 4th edition of the Data Scientific Bootcamp. It's going to start on the 1st of October. It's going to be during 9 months. And so if you are interested, you can always try to find me. I will not be at the job fair, but I will be around. You do have my email address, so I hope that I will see a few of more here. Thank you for your attention. pas facile.
So here we are. When we did the call out in January to find out who could be the next keynote speaker who could close our event, we had names like Stephen Brobes, but he came this morning, and other names. One name that came a lot was Luc Julia, based on this book that he made, a book about artificial intelligence, and a book also saying that artificial intelligence probably does not exist. I will let him explain what he really means, because Nathanael there really believes that it's not a hype. So, Luc Julia, the floor is yours.
Thank you very much. Okay, so I'm Luc Julia, and I'm going to, I'm Luc Julia, okay. I'm going to tell you about the fact that in French and in English, there is no such thing as artificial intelligence. What does that mean? It means that the artificial intelligence that people are talking about for the past now, I would say 6-7 years, this is the one that doesn't exist. I cannot take it anymore. There is a lot of crap, a lot of things that are not true that people are saying, and what I'm going to do today, I'm going to tell you the truth, okay? So to tell you the truth, I need to start to define or try to understand what is artificial intelligence and how did it start. Back in, it went way too fast here. Yeah, this thing doesn't work. Okay, that's fine. So back in, okay, I don't see anything. I don't have a return on my slide, right? Okay, that's fine. So back in 1956, there were some people in Dartmouth University who decided to create artificial intelligence. They decided that they did create artificial intelligence. Why? Because they did succeed to model in a very, very easy way a neuron with a mathematical function. And from that, by extrapolation, they said, if I have a neuron, I have a network, a neural network. And if I have a neural network, I have a brain. If I have a brain, I have intelligence. So it was a little bit of a shortcut, right? So the reality is that they had nothing because they failed at doing whatever they were trying to do at the time. But I'm going to go back to that. Before, changing all the time. Okay, let's try again. I'm not going to. I need to use the thing. Okay, I use the button. No, that's fine. Okay, so even the button doesn't work. It's slow. Okay, that's fine. Yeah, okay. I won't comment on that. Okay, it's coming. Okay. For me, the artificial intelligence, if I had, because I'm French, I'm very French, I could start artificial intelligence actually back, 300,000 years ago. Because basically, as soon as we built a tool, it was artificial intelligence. It's something that is going to augment ourselves. It's something that is going to be of use to us. And it's something that is going to do something better than what we are doing. Okay, this is what artificial intelligence is going to be after all. So, but I'm going to start, the story, my history of artificial intelligence. I'm going to start it in 1642 when Pascal created the Pascaline, which is the very first calculator, basically. Very first calculator that allows people to calculate and to do some very simple addition and subtractions, that is something that we should be able to do ourselves very easily. But right now, if I'm asking, how much is 842 plus 695? Wow. Zero answer. Of course, the machine, even the Pascaline, would have calculated that, in about 5 seconds at the time, right? So in your case, I'm very surprised that nobody did it. But even if somebody had done it, it would have taken you, a little bit of time, and most likely you would have been wrong at 20% of the time. The Pascaline was right all the time. There's the difference between the machine also and us. But we'll talk about that a little bit later. I'm going to come back to my good friends in in Dartmouth University. The issue, not only that they had was the fact that they chose to model something that is wrong, but they started to try to tackle a problem that is very, very difficult, which is certainly the most difficult problem in the world, which is natural language. Right? Natural language is very, very difficult to tackle. We still didn't succeed to tackle it today, right, with all the methods that we used. And of course, what happened, in the early 60s, they failed. They didn't succeed with the machines that they had at the time, with the methods that they had at the time. They didn't succeed to do anything, and started at the time what we call the first winter of AI. And the issue, and why I'm here today, is that I'm afraid that a new winter of AI can come if we continue to promise things that are not going to happen. At the time they promised something that didn't happen, the funding went down, and it was the winter of AI. Today, there are a lot of people that are promising things that will never happen. There are a lot of people that are trying to scare us with artificial intelligence, and there is no reason for that. So that's why I want to explain exactly what it is that we are doing and why we should be afraid of, but we should be afraid of it by understanding it. And anything that is going to be wrong with it is because we are going to decide it. So I'm going to continue to talk about the other kind of methods that were used at the time. In the 60s, 70s, we started to do expert systems. Expert systems are basically rule-based AI. And it was working very well, and it was working that well that in 1997, basically a machine that was called Deep Blue did beat a human at chess. It looks very intelligent, but the reality is that there was not much intelligence in this thing, because chess is a simple game with rules, and mathematicians are saying that there are about 10 to the power of 50 possible moves at chess. And what we succeeded to do at the time was to have all the moves in memory of the system, and the ability to calculate any path between the different moves in order to find the victory. But it's not really the point. The point is that there are several methods to calculate these kind of things, and artificial intelligence is a mix of all the things that we learned in the past 60 years. Could be system experts, could be also those neural networks that people were continuing to work on, even though it wasn't very popular at the time. But something happened in the mid-90s again, and this something is the internet. The internet is very interesting because it is a lot of data. Lot of data. It's basically the biggest database in the world. And what we were missing at the time, in order to prove some of the things that we wanted to prove, was to have access to data. And with the internet, we had access to data. And so that's why, in the mid-2000 now, we were able basically to prove some of the techniques that were called at the time machine learning and deep learning. The reality, the thing that was also interesting on the internet at the time, for a reason that I cannot explain, there were a lot of cats on the internet. So there you're saying, don't understand where he's going, but I'm going there if the cat appears. Here it is. So lots of cats on the internet means that we were able to create some systems that were, image recognition, and in this case, recognizing cats in an image. We were able to prove that because there were lots of cats, but we created those systems that were able to recognize cats at about 95% accuracy. Means that it wasn't recognizing cats, for instance, in the dark, or it wasn't recognizing cats that were drawn by Picasso. But it was doing a pretty good job. But the reality, what was very interesting there, is that to do that, roughly, to create a good system, you need about 100,000 instances of cats to recognize the cat. So, okay, that's fine. But now the question is really, is it really something that is close to our intelligence? Do you have any idea how many cats do you need? Your kids, that are 2-year-old kids, need to recognize a cat forever, even in the dark, and even drawn by Picasso. Any idea? 3. The psychologists are telling us that it's 2. My 2-year-old daughter, she needs only 2 instances of cats to recognize cats forever. What I'm saying here is that basically the methods that we are calling artificial intelligence have nothing to do with the methods of our own intelligence. So this is one of the proof of it, but I have another proof that is even more interesting, I think, which is the one coming from, it's going to come soon, hopefully, from the, yeah, it is. So coming from what happened between 2014 and 2016, where the machine this time beat the human at Go. Go is a little bit more complex than chess in the sense that it's not a finite game. So you cannot really calculate how many moves you have. And mathematicians are going to tell you that there are between 10 at the power of 172 and 10 of the power of 762 possibilities, which means basically what I just said, that we have no idea. But it's not the point. The point is that here we were able to create some systems that were doing a mix between machine learning by putting a lot of recorded games in the machine and rule-based, and we were able to create a system that did beat the world champion at Go. It was very interesting, but what is even more interesting is the power that is being used by those machines. The machine on the left is DeepMind, and that is running AlphaGo. And DeepMind has 1,500 CPUs, chips inside the computer. 1,500 CPUs, 300 GPUs, and GPUs are graphical processing unit. It's basically matrix calculation. And 30 TPUs. TPUs are very specific processors for TensorFlow, basically, for the one who know. This is basically an AI framework. But anyway, so let's say 2,000 processors. 2,000 processors to just play Go. Okay? The 2,000 processors, it's equivalent to a small data center, if you will. It's 440 kilowatt an hour. 440 kilowatt an hour, just to play Go. The guy on the right is a human, nothing in his pockets. He just has the brain. You have any idea how much the brain spends in terms of energy? 200. It's 10 times less. It's 20. So it means that the machine is developing 440 kilowatts, where we do develop 20 watts. And the machine is just playing Go in this case. We hopefully do something else. Okay? So between the 100K against the 2 instances of cats and the energy that is deployed to play Go and just Go, and the energy that we deploy to play Go, and it shows that the techniques that are being used by the computers, the AIs, and our techniques have nothing to do with each other. Another thing, since we are talking about data, I want to touch a little bit about one of the big issues of the artificial intelligence today is the data bias, right? When you create a system, you potentially, you have to choose some data. When it's cats that you have to choose, it's pretty simple because, you can recognize very easily and you can sort yourself very easily what are cats and what are dogs, and you're going to use dogs, in your model of cats. But some things are much more complex and much more difficult to find. Even though there were, a lot of data, there is a lot of data on the internet, there is sometimes, not enough for what you want to do. In 2016, Microsoft wanted to create a bot in order to go to promote the Microsoft products on Twitter, which was, a very good idea. So they created a bot that went there, and it was called TAY or T-A-Y. And unfortunately for them, they had to unplug the chatbot after 16 hours. Because in the history of chatbot, if we can say something like that, in the history of chatbot, it became the most racist and sexist bot in the world in 16 hours. How? Why? Because they chose basically 2 wrong things. At least this is what the community thinks, but I'm going to give you some ideas of what can go wrong. The first thing is that they chose a a factor of adaptability that was too high. Adaptability is what? Is when we create a system to go to talk with a very specific public. You want to adapt to this public in order to react like them. And I'm told, I'm not on Twitter, but I'm told that on Twitter, after 2 or 3 interactions, you are insulting yourself, or people are insulting themselves or whatever. So the adaptability factor was a little bit too high to be like the population, of Twitter in this case. But the main issue there was the choice of the data. There is not a lot of database of conversations. So it's very difficult to program a bot by just using the data. But there is a database that exists since the 50s that is called Switchboard, that people that are doing speech recognition and that are doing natural language are using for a long, long time. Switchboard is basically annotated database of conversation that did happen between people on the phone back in the 50s. And what happened there, what could have happened there, is that Microsoft chose a subset of Switchboard that was maybe the conversation in the south of the States in the 50s. So that's why, if the system is wrong at the beginning, it's not going to go the right direction. So between the adaptability factor and the fact that the wrong data was chosen, the system became racist, and sexist very, very rapidly, and they had to unplug it after 16 hours. One thing I want to talk about very quickly is the inexplicability. So we are often told that AI is dangerous because it's a black box. The reality is that it's not a black box. The reality is that there is no inexplicability. So let me explain what that means. It means that theoretically, you can explain everything. Remember what we have, the system that we have, they're all based on mathematics and statistics, okay? So we choose the parameters. Sometimes in deep learning, and most likely in deep learning, the parameters are going to be chosen by the machine, and it's going to be very difficult to follow the path because there are millions of calculations that are going to be made every second, right? But theoretically, you could, if you had 1 million lives or whatever, you could follow the path and you could explain. Practically, you cannot do it because there are too many calculations and there are too many things to look at. But there is no inexplicability, so there is no reason to be afraid of the system themselves. There is only one reason to be afraid. This is being afraid of us and not of the systems. One other thing that bothers me a little bit when we are talking about artificial intelligence is the autonomous cars. So back in 2018, in January 18, when at CES in Las Vegas, everybody was saying, okay, autonomous cars, they are coming. It's going to happen in 2 years, 3 years, 5 years, but it's coming very, very soon. And in CES 2019, people started to say, okay, maybe it's not going to happen that soon, it's going to take a little bit more time. So, but 5 years, 10 years, it's going to happen. First of all, we need to understand what autonomous means, okay? So in the domain of autonomous driving, there are 5 levels, basically 1 to 5, and 5 is the full autonomy. Full autonomy means you can drive anywhere, anytime, and you have the same exact kind of reactions that a human would have, right? Today, there are cars that are already, level maybe 3, like the Teslas and stuff like that, okay? So you have systems that are already autonomous enough, I would say, that are going to save a lot of lives and to help a lot people who are not comfortable driving or whatever. But the scoop that I'm bringing you today is that autonomous driving level 5 will never exist, never. Not in 5 years, not in 10 years, not in 50 years, never. Never with the techniques that we are using today, which are those statistical and mathematical techniques. And for that, I'm going to give you 2 examples that you can think about, and we have many, many that we can think about. The first example is if you are unlucky enough to know in Paris the Place de l'Étoile, which is basically place where you have the Arc de Triomphe and you have something like 12 streets that are coming at the same place, and it's always, a big mess with the cars. I mean, if you put an autonomous car there, it won't move, basically. Okay? It won't move because the rules that are applicable in Place de l'Étoile are not the rules of driving. They are something else. This is a lot of sociology. There is something else. Negotiation, I mean, whatever. You can tell me, I mean, I can always learn, the negotiation. I can always have some systems, that are going to be negotiation between the cars and stuff like that. Yeah, you can do a lot of that. But then I can bring you to Bangalore, and we can talk again. So that's not really the point. There are many, many other examples. And recently, I actually found a very interesting example on the Waymo database. So Waymo is the Google subsidiary that is doing a lot of, that is the most advanced, I think, company right now in autonomous driving, because they did, for the past 7 or 8 years, they did put some cars on the road, in California and other states, and they have recorded something like 11 million miles of driving. 11 million miles, it's a lot of miles. And they gave the community, basically, the access to some of those videos, those shootings, in order to understand, what they can do, and maybe to use that for training. And if you want, this is on YouTube, you can go to watch those videos. And there is a video that, for me, is very, very interesting, where you see, shooting. It's not very exciting, frankly. I mean, you have the windshield that is there, the camera is there, and you see, basically, the car driving on the road. So looking 11 million miles of that is going to be a little bit boring. But, sometimes you find some gems, right? And recently, I found one that was pretty cool, where you see a car driving. I mean, you see the car there, and you see it in the middle of the road. And then, there is no reason it stops, middle of the road. Then starts again, 2 or 3 meters, stops. Starts again, 2 or 3 meters, stops. And then, I mean, you have the feeling, you don't know exactly what is happening, but you have the feeling that the operator of the car, takes back the control, and drives away, because the guys, behind him, I guess that they were a little bit nervous. So anyway, now you are wondering why. Why did this car, stop like that several times? And you watch a little bit closer the video that is there, and you zoom on the video, and you look on the right, you see on the sidewalk, you see 2 guys walking. Okay, not very interesting, but then you zoom a little bit more, and you look at that closer, and you see that one of the 2 guys walking on the street there, on the sidewalk, on his shoulder, he has a stop sign. You don't have it? Okay. So you, hopefully, if you are driving and you see a guy with a stop sign on the sidewalk, you are not stopping. The car did stop, okay? So, of course, now I'm sure that somewhere in the rules, in the thing, there is a case that says, if there is a jerk on the sidewalk, with a stop sign, I mean, just continue. But I mean, the reality, what it means, basically, and this simple example shows that you cannot have all the examples, all the possible things that are going to be either in the rules or the data set in the world of driving or any other world. So it means that it's going to be just impossible to have something that reacts exactly like a human will react unless you add, a lot of random in this thing. One point that I want to make also, I'm always, I'm often asked about Siri and why did Siri have success, and actually I'm kind of sorry that because of Siri, we made people believe that it could be intelligent, So we added a layer of anthropology, basically, on Siri that we shouldn't have added. Because now, it did bring movies like Her and things like that that made, people believe that potentially Siri is smart. Siri wasn't smart, and actually it was maybe less smart than other systems that were competing with us. But if we had the success that we had, it was just because we recognized that we didn't know. So we knew that the technology wasn't that good, and because we knew that the technology wasn't that good, we added what I call the artificial stupidity. Artificial stupidity is basically a very basic, based on the very basic system or theory that I built over the years that I call the nightclub theory, okay? What is the nightclub theory? The nightclub theory is that you are in a nightclub, there is a lot of noise, you are a little bit drunk, and people are talking to you. You don't want to be stupid, right? You don't want to look stupid, so you are going to make an effort, you know, to understand this person. And after a while, I mean, the person understands that, I mean, might understand that you don't understand, so you are going to react in weird ways. So at the beginning, you're just going to do like that, but it doesn't, you know, it doesn't last. And then, you know, after a while, you just talk to the person, but by saying something else than what the conversation was about. And this is exactly what Siri was doing, you know, when he didn't understand people. He's just, you know, making some little jokes, like we said. And we did hire a lot of people that were not from the domain of computer science or the speech recognition or natural language. And we did hire, you know, people from Hollywood and that were doing the scenario. And we just added, you know, those little things that made it look more human, where it was actually totally stupid. But it's our fault. But in the meantime, I'm not going to spit on the success of Siri, because we also saved some lives. So it seems to be a little bit weird that Siri saved lives, but there is one story that I like to tell. Is a guy somewhere in the States in 2013, he was working on his car in the middle of nowhere, and the car, you know, fell on him, and he was totally, you know, stuck under the car. And there was no way he was going to be saved because there was an issue with the leg or whatever, you know, that was bleeding. And nobody would ever come, you know, to this place. And he was going to die until he realized that, you know, he had the voice still working. Even the rest, you know, was totally paralyzed. And he just said, "Hey, Siri," and in his back pocket, you know, the thing didn't, and he said, "Call 911," and that saved his life. So there is, you know, some good stories, even though, you know, I'm not very proud of the technology itself. Now I want to say why I don't like to talk about artificial intelligence and why I prefer to talk about augmented intelligence. I'm talking about augmented intelligence not because of the discipline itself, but because of what I said earlier about the tools, right? The fact that what we are building are tools. They are tools that are augmenting ourselves. Like any other tool, if we are building them to be better than us. Like we talked about, you know, when I talked about the calculator from Pascal, it's just better than us, right? At a very specific task. So we are building all those tools to augment our intelligence, to augment ourselves. It could be a cobot, it could be anything, it doesn't matter what it is, but this is what we are doing. Now, in order to conclude, I want to talk about intelligence. I mean, you noticed that I didn't talk about intelligence as well. I don't know what intelligence is, right? That's why I'm going to talk about intelligences, right? I don't really know what it means, but I'm going to plot here, you know, what the human intelligence is, against the robot, the AI intelligence. On this side there, you have the level of intelligence, whatever it is, 0, Trump, to 100. And on this side here, you have all the different domains of intelligence, okay? Whatever it is, I don't know exactly, but we'll see, we'll give some examples of that. First, I'm going to draw us. We're okay. You know, we are not geniuses, but we are doing pretty well. But what is interesting there is that we are doing pretty well everywhere. This is a continuous line, okay? We are doing pretty well everywhere. But what is even more interesting is that we are doing pretty well even in something that doesn't exist yet. We know that we'll be doing pretty well because we are going to adapt ourselves very, very fast. And we are going to be able to invent the line, and we are going to be able to follow the line. Okay, so not only we are continuous, but we are infinite. Now, if we are looking at some very specific domains, I'm going to take chess, for instance. So this is me at chess. I'm okay. I drew the slides, so I do whatever I want, but I'm not that good. But anyway, I'm okay at chess. But we saw, in the example earlier, that now the machine is much better than we are, because the machine has all the solutions, right? So the reality is that chess today, is there. Chess is a genius, right? The machine is better than us. And by the way, in everything that I'm going to draw, the machine is always going to be better than us. Again, because we are not going to build tools if they are not better than us. It doesn't make any sense. So here it's just, just genius. Then there is Go. Go is interesting because it's not only better than us, but it's better than genius. Because, of the number of moves that I was talking about before, I mean, there are many, many moves that don't exist that the machine can know, and so the machine do them. It's still under the rules, but it has many, many more abilities than we do. Then there is driving. Driving, as I said, never will have a genius. Level 5 will not exist, but we will have level 3, level 4, and it will save a lot of lives. It will be very, very good. It will be better than us. Us, unfortunately, we're driving, we are texting, we are drinking, we are doing, mistakes. Machines will do mistakes as well. There is always somebody who will just, run against the car or whatever. But there will be accidents, but there will be much less accidents than what there are today. Now I'm going to talk about quickly another one that is a connects domain here that is delivering. I don't know exactly what it means, but it's related to driving somehow, and machines are pretty good at delivering. But I put that there. I will explain why in a second. And as I said, I can take any domain, any game, anything. We will always be able to build a machine in a very specific domain with the right data and the right rules that are going to be better than us. Okay? But what is interesting there is that what I just drew there is not a continuous line. Okay? In mathematics, it's called discrete, right? And if you want to have something discrete that is going to cover a continuous line, it's called infinite. It's a lot of continuous line of lines that you need to draw the continuous. So the message here is that we will never be able to cover all the spectrum that the humans can cover, because it will require a lot of tools, a lot of systems in all those things. But in addition to that, there is the issue of power that I was talking about before. In every single of those lines, it requires a lot of power. If we continue to build those systems the way we are building them by using, again, statistics and mathematics, we are going directly in the wall, because we are going to have to build way too many big data systems that are going to require a lot of energy, much more energy than what we have on Earth today. If I look at this particular place here, like you can imagine between two discrete lines, you actually have infinite. So it's very complicated to do learning of even connects domains. So we can do a lot of learning between domains, but still it would be very, very difficult to have a full system learning from a very connected domain. And what is even more interesting there is what happens here, right? Right here, actually nothing happens, okay? Because the techniques that we are using, that are those techniques, again, based on data or rules, if there is no data because we didn't invent this thing yet, and there is no rules because we didn't invent this thing yet, so there is no artificial intelligence there at all, okay? So basically, the message that I wanted to bring there is that artificial intelligence is complicated sometimes, but we are in control. We do whatever we want with those tools. We need to learn, we need to understand that there might be issues, but the issues are going to come from us, not from the system themselves. They're not going to take any decisions by themselves. We are going to program them to take decisions sometimes, but this is our fault. If something wrong is happening, like any other tool, you can take the knife, you can take a nuclear weapon, you can take whatever, any other tool, we are in charge, and this is our decision, this is our issue. Okay? And now I don't want you to believe that I'm saying that artificial intelligence is with no use. There is a lot. We just started, right? Even though we started 60 years ago, as I said, officially, we really started, in 2007 or so. And there is many things to do yet with the current techniques that we are using. So doing some image recognition using deep learning, machine learning, expert system, whatever you want, we are still going to create some incredible, useful systems. And we shouldn't stop now, okay? And that's true for vision, that's true for natural language, that's true for all the domains that hopefully you are working on, because we have a lot to do. But we cannot say, and we shouldn't say, that those machines are going to replace us as humans. They are going to replace us in some of the tasks that we decide that they are useful. But this is, again, our decision. Thank you.
Thank you very much. If there is does someone has one question? Nobody? So let's move on to the wrapping up of the event. It's hot, so everybody wants to wrap up. We are going now to nominate the startups and the scale-ups and the AI awards. But before we do that, I will ask Isabelle Grippa to come in, who is next door. Hold on. So if you look on the app, we have a few winners. And one of the winners that I want to announce is the winner of the person who was the most active during the event. Can someone tell me who it was? The person who was the most interactive during the summit. Check the leaderboard. So I have three winners here. I think Patrick did a very well catch up in the end of the evening. So I have Tim Janen. Where is Tim? In here. Tim, can you come one second here? Kevin, I think he's next door. Is number 2, Kevin, is he here? Kevin, is he gone? Can you come because you're number 2? And of course, Patrick, who is number 3, who did that excellent catch-up at the end, that last sprint. So these are the people who were the most interactive during the event. Can I please give you, take a beer, and let's give them a very warm applause. And now is the time. Oh, there is Patrick. Let's do it again. Oh, yeah. Did you see that only when I said take a beer that Patrick stood up and came? I hope it's full. Well done. Thank you very much. Thank you for your interaction. So, can you call the Isabelle as well, Kieran? I was hoping that Isabelle would come in. Maybe we have to beg or shock. Are we ready? Can you come? C'est à vous. Non, aucun stress, tout va bien. So to help me with the awards, I've asked Isabelle Grippa to come in. Isabelle is, there is a microphone there that you can use. Check it.
1, 2.
All right. Isabelle is the CEO of Hub.Brussels. And can you, in a few words, introduce Hub.Brussels and say what Hub.Brussels does?
Yes, of course.
Yeah.
Yes. Hi, then I'm the new CEO of Hub.Brussels, Isabelle Grippa. And thank you first for giving me the opportunity to hand out this AI awards to promising individual startups and scale-ups in the field of artificial intelligence. And then Hub.Brussels is brought to support this the 5th diSummit and this first ever AI awards. Then Hub.Brussels is the new Brussels business support agency resulting from a merger between Impulse, Atrium and the Foreign Trade Agency of Brussels. And today, Hub, what's Hub is? Hub is an agency composed by 320 employees based on Brussels and all around the world, and in more than 90 countries. And from your first steps as startups, as you, through your growth and international development, Hub.Brussels is there to support you free of charge, whether it is with advice, business plan, grants, or individual and group coaching. Hub.Brussels is particularly committed to supporting the Brussels digital ecosystem. This is why our agency ensures coordination of the Next Tech regional digital plan, which focus is on AI, big data, and of course virtual reality. And in concrete terms, the Next Tech plan has been able to contribute to financing the activities of DigitYser, which is an incredible space for meeting and emulation. Well done to Philippe and all the team for having. Well done then to Philippe and all the team also for having made DigitYser such an inspiring space in a very particular neighborhood which is growing now in Brussels, Canal Zone. Brussels also supports a community of entrepreneurs and promotes synergies with the world of research through its ICT cluster software Brussels, which brings together 140 businesses, of notably 10 of which are startups working in AI. Then, please don't hesitate to contact our agency. We have a new website since yesterday, www.hub.Brussels. Don't hesitate, we are there to provide you support. Thank you.
Thank you very much, Isabelle. So if you are a startup, you don't know where you will put up your office yet, stay in the region of Brussels and you get the support from Hub.Brussels, as you just heard. So here are the results. The results are your results. You have been voting. Yeah, don't blame me for any false results anymore. This is not possible. That was in version 1. So you have been voting over the past days for 3 categories. So of course we have personality, we have startup and scale up. So let's see who are the top 3. So on personality-wise, we can see, if you can call, that Rachel Alexander is the AI personality of the year. Is she still here? Come on! Is Ségolène still here? Ségolène, are you still there? Ségolène? So you will have, out of the hands of the CEO of Hub.Brussels, this prize called Three Women. Yeah, and Chris, I know you've been in the lead very long. You've been in the lead very long. So, congratulations. Next one. It's for AI Awards. And who do we see here? We see that Complete Data is the winner, followed by Chatlayer and Open the Box. Can these gentlemen come on stage, please? Of course, you could follow the results, so there is no real surprise. Well done, well done, well done, well done. This is the one. second. The beer is the second prize. Yeah, take the beer. Okay, let's move on. The best scale-up voted by the people who attended the diSummit this year is Faktion. Niels, you did well to stay this extra 5 minutes. Well done. Good. So that's it. Can I please ask all the coaches, all the speakers, all the trainers that have spent so much time preparing this event to join us on stage for a final picture? Come on. Fanbase, hein? C'est moi, il suffit d'appeler son fanbase. Hein? Regarde la méchante. Oh, oh. Quoi, on a mangé un couscous là? C'est pas l'italien? All right, thank you everyone. And can I ask the people all the volunteers and all the people, Mathieu, can you just call the girls and the volunteers in to come on stage so that we can wrap this up? And I will want to give the final word to you, of course.
Okay, I guess we need to wait for the
other
guys.
Coming, I'll get them.
Okay. Wow, what a day. Oh, Philippe is disappearing. Well, what do you think? Do you like it? Did you like it? Yes, no, yes. As far as I'm concerned, I met more people today than in the past 6 months, and it is not that I've been always locked up in my office. Of course, I'm meeting people every day, but today it has been really a whirlwind, really crazy, and I hope that has been the same for you. I hope you did the homework I told you to do this morning, so go out, network, and work. Have you done that? Yes. Have you done that?
Yes, of course.
We are all tired. Please go ahead.
So that's it. I would like to thank all of you because you've made the day with your effort, your preparations, everything you've done to make this day to a perfect day. I cannot be more grateful than that. I would like to name you, each one of you individually, but I will do that in a tweet after that. Thank you for being here. Thank you for you, because this is your event. We want to do better next year. Is there any news about next year?
Let me think about it. So I guess we all love the format this year. I don't know if you have noticed, we have a little bit reduced the quantity of talk. I think the quality of talk was certainly not less, maybe better than last year. We want to continue and be better, but we don't know how to crank in more things. What would you do in our place? How would you improve the number of talk without reducing the quality? Any idea? Any idea? Say it again. 2 days. Should we do it? 2 days?
Yeah.
Should we really do it? 2 days. That means that you will have to be here tomorrow, for instance. Is that good? I'm not so convinced. Okay, yeah. You wanted it. You asked for it. We listened to you. We are going to do that 2 days next year. So please note down the date. It's going to be the 24th and 26th of June, 2020. 24 and 25 of June, 2020. Is that a good...
Thank you very much. Thank you to all the volunteers. For all the volunteers.
Thank you all for being here. This has been a fantastic day. Let's meet you all next year.
Thank you. Bye.